Good morning, grade 10s, and welcome to this morning's mathematics webinar. As you know, I always allow for 2 minutes for some attendees to still sign into today's session so that we give everyone a fair chance. So I will allow another 2 minutes. I will be with you then. Right, good morning, grade 10s, if I haven't greeted you yet, and welcome to this morning's webinar. I hope that all of you are still safe and healthy at this stage. Right, before we start, I would like to go over some basics so that everyone know how the session works and what is expected of you. So for those of you who don't know me by now, my name is Linky Young. I am the Chief Education Specialist at Impact for Maths and So if you're struggling to hear me, please make sure that your audio is on and that your speaker volume is turned up. I just want to mark that for everyone that can't hear me. You will automatically be muted when you join into this session. There will be stages where I will ask you if you have any questions, and then I will unmute you. You will have an opportunity to ask your question, and I will as well. Should you have any questions, you can raise your hand or you can write it in the question box. I will allow sometimes for you to raise your hand. So don't do that during the session. I might miss your question then. So keep your questions for the times that I ask you to raise your hand. Right, let's quickly test that raise your hand icon. So you will see there's a little hand over there. Put up your hand. Let me so that I can see if you can hear me and you know how to use that icon. Yes, the hands are coming up. Yes, all right. It seems like everyone found the hand and is using it at this moment. You can download this presentation in PDF form in the handout box on your dashboard. You can do that during the webinar, but if the webinar ends, it won't be available for download anymore over here. You will be able to download it on the guided learning platform under resources as well. Right. You will also find all of this information in the question box below or on your right-hand side. Remember to send us your questions. So if you don't feel comfortable in asking your question online, you're welcome to ask it in the question box. You are encouraged to ask your questions or leave comments. However, should you leave any irrelevant or inappropriate comments, you will be dismissed from the session. If we don't get to your question today, I'm sure I allow some time for that. And you still have an academics question, you're welcome to send a message or an email to academics@impact.co.za. All the questions in the question box will be answered during this webinar, or it usually works out that the time allows for that. But should I not, I will provide feedback to each and every one of you that is part of this session. If you don't receive answers to the questions and it was not answered in the webinar, please send us an email to info@impact.co.za. So Impact has launched their own YouTube channel, and all of these recordings of the webinars that was presented and is going to be presented and is currently presented will be uploaded on that channel. I will share that link for you at the end of this webinar. Right. So let me see, is everyone ready? Can we carry on? You can put up your hand just to show me that you can still hear me. Yes. Right. Thank you. So let's start with today. So I just want to have a quick overview on the topics that you need to know for term 2. And the whole aim of this, and why I repeat it every time, is that that you are sure that you know what to cover and that you can work on your own as well to cover all the topics that you need to have for this term. Right, so you need trigonometry, and we've done a lot of trigonometry in our previous webinars as well as the notes. Now, all of the recordings of the webinars that we have done can be found on the YouTube channel. As I said, I will share that link to you later on. The notes is available on the guided learning platform under resources. So please go onto that platform, go and have a look what is over there. There's a lot of resources and video lessons uploaded there for mathematics as well. All you need is your student number and your ID number. Right? Also is functions and Euclidean geometry. Today we will start with functions. And it's an introduction to that, so we're not going into it too deeply, but this is the basics that you need to know to actually complete your functions successfully. All right, so the next webinar, we will continue on this. Let's look at functions. Now, you've heard of functions a lot of time, but I'm sure you're not 100% sure about what it is. So we will get to all of that today. You will find functions in paper 1. Now I want you to listen very carefully. Functions of trigonometric expressions or equations you can expect in paper 2 as well. All right, so functions is a topic that is mainly assessed in paper 1, but you can expect trigonometric functions in paper 2. Just like trigonometry is in paper 2, the functions can also be expected in paper 2. Right, but mainly functions are assessed in paper 1. So please make a note of it for yourself so that you can remember about that. So what we're going to do in functions today is the concept of a function with input and output values. Now, I'm sure those two terms is not new to you. You've heard about input and output values before, and you actually started with that in grade 4 already. If you can remember that, we call it the spider sums, where you have some numbers that you put in, you apply a rule, and you have some output values, their answers in the end. Then we are going to do point-by-point plotting of basic graphs, investigate the effect of the parameters A and Q, point-by-point plotting of basic trigonometric graphs, investigate the effect of the parameters A and Q on trigonometric graphs, sketching of graphs, find the equation of given graphs, and interpret graphs. Now, if you look at all of these topics and content that we need to do in functions, there's one big word that actually stands out. It gives you a clue as to what functions actually refers to. And I want you to think about that. You will see that later on as well. Think for yourself. If you look at these words and and look what is actually repeated a lot of times, it will give you a clue. Right, so for today, we will look at the concept of a function with input and output values and point-by-point plotting of basic graphs. Now we're going to look at two basic graphs over here, and it will be the straight line and the parabola. So what is a function? So I said that you must look at the word that actually repeats itself. It should give you a clue to something like a graph, but it's a very specific type of graph. We will look at that. Functions allows us to see the relationship between numbers in terms of graphs. It makes it easier for us to then interpret data in the form of just numbers. So what it says is, it takes a lot of data, a lot of numbers. So if you think of statistics and they give you all of these numbers to work with, you can't actually see if there's a trend, meaning does all of the numbers move upwards, or do I have something like this? And that is what a function does. It takes that data and it actually represents that visually for you to see. So it makes it easier for you to interpret that because you can see it visually. How is it represented? In terms of a graph. Okay. So the word that I wanted you to pick up in our previous slide is the word graph. So a function is a graph, but it's a very specific graph. Now, this is a very mathematical definition of a function, and it says exactly what we said now. It's a mathematical relationship between two variables, where the input variable has one output variable. And that is what a function is. One input variable will only yield one output value. So this means that if I have an x value that I substitute into an equation, I only have one y value that it yields. So your input value is your x value. Your output value is your y value. And that is the two variables that they talk about. This graph that you're going to draw will show you the relationship between your x and your y value. So that is your two variables. One is your input variable and one is your output variable. So we said that these two variables is your x and your y values. So I am going to use this diagram to actually show you what this means. And I'm going to use the original spider sums that you are used to from your very lower grades to actually explain this. So in the middle, you have your function, or you actually refer to that in the lower grades as your rule. That is the rule that you're going to apply, your equation that you're going to apply. You will have several inputs over here. We call that our input value. Now we said that the input variable has only one output variable. So if I have four values going into this application of the rule of a function, I am only allowed to have one for each of the x values. So if I have four input values, I need to have four output values. And we already said that my input value is my x value and my output value is my y value. Right, quickly put up your hands. Let me see, are you still with me? Are you okay? You can still hear me, you're following me. Right, awesome. Yes, there's a lot of hands. All right, I'm going to take down the hands for now. We are going to use, firstly, we're going to use a table to find input and output values. And this will also be your starting point when you need to draw graphs. Right, so I'm going to start with a table, and I chose some input values for x. So if you look here, I chose a few x values, and just to mix things up, I chose one y value. Now you will see I only chose one of the two variables because I need to find the next variable, the pair, his friend. I need to find that, and we're going to apply a rule to that. So another tip that I want to give you is when you are asked to draw a graph, before you use all of our fancy things to identify it, you will use tables in the beginning. Choose your x values that has negative values as well as positive values. Right. So I want you to have negative values as well as positive values. I think there should be a -1 though. So -2, -1, 0, and 5. Right. Let's carry on. Now there I've given you the equation that you're going to apply, the rule that you're going to apply. Right, so the rule that is given to you is y is equal to x plus 3. You're going to apply this rule to the values that is given to find the output value, your y value. So these are all the values that we want to calculate because we want a complete set of values for us to be able to draw a graph. So let's start at the first one. Let's look at what we have. We have an x value over there, our input value. We do have the equation or the rule that is given to us. What do we want? We want to find our output value, our y. And we're going to make use of substitution to get that. So you are going to take the given value or the chosen value that you chose, your input value of x, and you're going to substitute it into your rule to find your output. I'm going to take my rule. I'm going to substitute the value that I've chosen for x, and remember to take its sign with it. So -2, you need to substitute the entire -2. So -2 plus 3 is equal to 1. This means that my corresponding y value, my output value for this x value is 1. So for the next one, you're going to do exactly the same. What do I have? I have an x value. I have the equation or the rule that is given to me. What do I want? I want to find my output value. And I am going to substitute it into the given formula. Equation. So -1 plus 3 will give me that y is equal to 2. And I'm going to do exactly the same for the next one. I have my x value, I have my equation, y value. So I'm going to substitute my x value into the equation and find that y is 3. So the next one is a bit different. Now they give me the output value and I need to find my input value. So what do I have? I now have my y value, output value, and I have the equational rule. I want to find my x value, my input value. You're still going to follow the same steps. You're going to take the equation. Now you're going to substitute the value of y and not of x. And then you're going to solve x by using inverse calculation. So x plus 3 means I need to subtract 3 on both sides. And you will find that so now we are going to use this information to actually draw your graphs. It is very important that you need to look at this values as pairs and as friends. So this x and y value will make one point on the graph. This x and y value will make 1 point in the graph. this X and Y will make another point, and so on. In the end, you are going to connect the dots, connect these points, and that will actually form your graph. Okay, right. So this is what you are going to do. For you to draw graphs, you will make use of just to quickly recap that with you, you will have your x-axis here on the horizontal and your y-axis is vertical over here. Right, so if I need to look at y is equal to 1, on your y-axis there is 1. You will draw a line through y is equal to 1. Here you will see that horizontal axis, you will go to -2 and you will draw your line through that point. Where these two lines intersect, where they cut each other, you will make your dot. And I'm going to show that to you now. So I said that you will look at your y value. Your y is 1, and you will draw a line through that. Then you will look at your x value, which is -2, and you will draw a line through your -2. Do you see that your two lines now intersect each other? Where they meet, that is where you will make your point, and that is that point-by-point plotting of a graph. So that is the second part of what we are going to do today. Now you are going to do this for every single point in this graph. So now I've drawn the one for x is equal to -1 and y is equal to 2. So I go to x is -1, I draw my line. I go to y is equal to 2 and I draw my line. Where the two lines meet, I make my point. For the next one where x is 0 and y is 3, so I go here, I see x is 0 there in the origin and I draw it actually over this axis of y. Then I go up to 3 on the y-axis, draw my line, and where the two lines intersect, that is where I will plot my point. And you do the same for the last point over there. Now, as I said, these points that you've drawn need to be connected to actually make your line. So you'll take your ruler and you will connect the dots, and that is how your graph will look. So this specific graph is a straight line. And I want you to look at the equation over here. Y is equal to x plus 3. X is not to the power of 2, is not to the power of 3. When you see that x is actually to the power of 1, because we don't write the 1, then you know you only have. Right, is everyone still with me? Are you happy? You can still see clearly, you can still hear clearly. Please put up your hand so that I can just confirm that. Thank you so much. All right, so it seems like everyone is still here and are still following. Okay, let's move on. So I want us to look at the following definitions. And these definitions have specific meanings that has to do with functions, with graphs. And you're going to use these definitions to actually explain your graph or explain its characteristics and actually give some more information regarding a graph. So the first thing that we will look at is the shape of a graph, the domain, range, axis of symmetry, turning points, intercepts on the axis. So let's just look at what each of these means and the words that you're going to use when you explain them. So when we talk about the shape of a graph, you need to be able to say, is it a straight line that we've just looked at? Or is it a curve? Curve means that it is bending, right? Okay, so is it a curve or is it a straight line? Is my graph increasing or decreasing? So is it going up or is it going down? My y values, is my y values increasing or is my y values decreasing? So you will have to be able to make mention of that. Throughout this webinar, I will make mention about a few of these things, but later on we will look. The domain is actually a collection of all the x values of this specific graph that you're working with. So all of the x values that this graph actually can define. So the range is then your y values, all your output values. An asymptote is the line that the graph approaches but never touches, or it never intersects. So I want to mention that a straight line, the one that we've done today, does not have asymptotes. The parabola that we're going to do just now also does not have asymptotes. But when we get to our trigonometric functions, your tan function does have asymptotes, as well as the hyperbola that you will do later on. But axis of symmetry, it is a line in which the graph is a reflection of itself. So you are kind of used, and you've used symmetry a lot. So where on this graph can I draw a line that represents an axis of symmetry? Turning point, it is the point at which the graph changes direction. So when you walk in a certain direction and you turn around, it's your turning point. And that is exactly what happens with a graph, especially with graphs that has to the power of 2 or 3, so your parabolas and ginomials. Right, so intercept with the axis, it's exactly what it means. So it's the point where the graph intersects the x-axis and the y-axis, and we call these the x and the y intercepts. Right, work a lot with these 2 points. So I'm just going to talk through this definitions with reference to this parabola that I've given here for you, and you will be able to draw a parabola like this. Now, if I look at this parabola over here, when we look at the shape of this, it's definitely not a straight line. It is a curve. When we talk about increasing and decreasing, it first decreases. Do you see it comes down? It means that your y value is decreasing. So it firstly decreases up to the point where y is equal to 1. Then it turns around. The turning point is over here. And now I have an increasing graph over here. So it is possible that you can have decreasing and increasing in the same graph. You will just have to make mention of the point where this turns around. My domain is all my x values, so this graph carries on and on and on and on, and x can be anything. So x is an element of real numbers. My y value only starts at 1 and then it moves up into infinity. Right, I mentioned that no parabola, or the parabola and the straight line, does not have asymptotes, and we can see that there's no restriction. A restriction means something that a value cannot be, and you get that when you work with fractions a lot. But there's no rule that says that x can't be anything. So x can be everything. It means that my line can go in any x, on any x value, and therefore there will be no asymptote. So if we talk about the axis of symmetry for this line, I know that I can fold it right over there where x is equal to 0. So if I fold it on this y-axis here, I will have a line of symmetry over there. We talked about the turning points. Let's look at the intercepts on the axis. So if I look at my x-axis, this line never intercepts the x-axis, meaning that there's no x-intercepts. If I look at my y-axis, I see that this graph intercepts the y-axis here at y is equal to 1. So your y-intercept will be at y is equal to 1. Right. So now that we've looked at the definitions, you have an idea of what each of them mean. And like I said, you are going to make use of that a lot during your work with graphs and functions. Right, so I want us to look at drawing different graphs. So we've drawn the straight line. Now I want us to draw parabola. So firstly, do you see the difference between the two equations? I showed you with the straight line, I only have an x to the power 1. That will give you a straight line. But when you have an x to the power 2, which is your the highest exponent of all the x's, so here are no other x's over here. So x to the power 2 will show that you will be drawing a parabola. Right. So I said that you can identify that when you have an x to the power 2, that you will be drawing a parabola. And I'm going to do exactly the same as what I've done with a straight line. I'm going to draw a table with x and y, and I'm going to choose some input values. Again, see that I've chosen, you can choose any of those numbers. No one is going to prescribe to you which values you can choose. So just make sure that you choose negative values as well as positive values so that you know how this graph acts and looks like on both sides of the axis. And then you're going to make use of substitution again. You're going to take your equation. You're going to substitute the given value, your input value over here, which is -3. Remember, I said that you must remember to add the sign as well. -3 squared, you are allowed to use your calculators over here, will give you 9. I'm going to substitute the next point in, which is -1, and that will give me an answer of 1. Substituting 0 will give me an answer of 0. Substitute in x is equal to 1, and we'll find that y is equal to 1 as well. And do the same for the last point over here. Right, so this is nothing new. We have done that with your straight line as well. And the following steps is also exactly the same as a straight line. You're going to draw a line for y is equal to 9 and x is equal to -3. And where those two lines intercept each other, that is where you're going to mark your first point. So I've done this for all of these points over here. I'll walk through it with you. So I said you're going to start with y is equal to 9. So on your y, x is equal to -3, so -1, 2, 3, and I draw my line where the two lines intercept each other at x is equal to -1 and y is equal to 1, and make my point over there. X and y equal to 0, at y equal to 1, x equal to 1, make my mark there. And as well with the last point where I have 1, 2, and 4. Okay. So what do you do next? You connect all of these dots, and already you know it's a curve, it's a parabola, so you can't take your ruler and make a V. You need to take your hand and draw a nice curve over here. So there you have drawn a parabola on your own. Right. Let's talk about the shape again. This is a curve. It's increasing and decreasing, or decreasing and then increasing at the point 0, 0. My domain is it can be any x value, so x is an of real numbers. My range is from 0 to infinity because y starts at 0 and continues into infinity. My axis of symmetry is still at x is equal to 0. And my turning point is right at the bottom there at the origin, which is the point where x is 0 and y is equal to 0. If I look at my intercepts, now all of my intercepts is over there. I have an x-intercept of x is equal to 0, and I have a y-intercept at y is equal to 0. Right, so it kind of cuts both axes at the same point. So I've put down some extra links for you to go and have a look at. So these are extra videos or extra practice or extra explanations that you can go and have a look at. I've also added links to our YouTube where it's impact videos where there's someone explaining the work to you and doing some worked out examples that you can work through. Given you the YouTube channel link where you can actually go and download the previous webinars as well as the recording of this webinar that will be available a bit later in the week. Right, so I am going to allow for a few questions. I'm just going to take it down the current hands. So if you have any questions regarding today's work, please put up your hand so that I can assist you. Let me quickly see somewhere there's a hand up. I just need to find it down the list. There we go. Michael Matthews, how can I assist you?
It's actually Michael Mateus, but yeah.
Sorry, I apologize.
It's okay. So ma'am, will we be able to see our exams? Because there have been problems in the cycle tests of the first term where there is mistakes in the memorandums where the students write and the memorandum's wrong.
Okay, so in those cases, in those situations, you are requested to just let us know and you can make that adaptation to the memorandum. You just need to keep it for moderation purposes. That is all. So you are allowed, the facilitator is allowed to actually make adaptations and just inform us about that. So if the examinations are marked with impact, it is not just one person that takes it and starts marking. So there's a panel of markers that sits together and they first have a memorandum discussion. So they need to go and work out the paper for themselves, identify alternative methods and alternative answers to questions, as well as make sure that there's no mistakes that they mark with. So then they come together and they discuss their findings, make the adaptations, and then on that worked memorandum, they take that memorandum and mark the work.
Okay, thank you, ma'am.
Pleasure. Right. Is it Mulanto?
Ma'am, I wanted to
Yes.
ask that when we're doing the parabola, why is it that when the last point stops at a certain, let's say, value like x value, right on the x-axis, why do you carry on with the line? Because in the textbook here, it stops.
Okay. So if there's no restriction given, meaning they said you should only draw it from x is equal to 3, negative 3 up to x is equal to 4, this actually carries on. Remember those values that we put on that table and that we draw is values that we chose. The equation did not tell us this is where it ends. We chose that as our last point. But if I chose 10 other points, it would be more. So with the parabola, if they don't restrict you to a certain amount or a certain x value, it does carry on. There's no restrictions on that equation, so it will carry on into infinity always.
Oh, and if they do tell you that there's a restriction, will they tell you plainly?
Yes, they will tell you very clearly. You only need to draw it from x is equal to -3 up to x is equal to 4. Then you only draw it in that part and you erase the rest.
Oh, okay. Thank you, ma'am.
The pleasure. Right. Next up is Nicholas. Nicholas, how
Hello,
can I
ma'am.
assist you? Hi.
I just want to know, can you have more than one curve in your graph? Is it possible to have more than one curve?
If they give you more than one equations, yes, then you on the same axis you can draw more than one graph, but one equation will not give you more than one curve. No.
Okay, thank you, ma'am.
Pleasure. Right, I'm just checking here. Tatu. Tatu, do you have a question?
Yes, ma'am. I wanted to ask, for the exams, is there gonna be like a specific date where we're supposed to write because of the corona? Did it get pushed back, or I've never really
Okay.
gotten a
So
answer.
Okay, so I know that yesterday the minister had a discussion on the TV as well for us to see on the press release, and they didn't make their final decisions yet. So as I know, it will be today where they will inform us all. So we are just waiting for Sakai, our examination board, to be more specific regarding that. I have heard, but it is not official. Please, everyone, it's not official that the June examination might be cancelled for now. I'm not sure how our examination board is going to handle that and if they are only going to push it back, but we don't know yet. We don't have any confirmation. As soon as we know, we will communicate that.
All right, thank you.
Pleasure. Right. Is it Zimkitata? Sorry, I'm so sorry if I pronounced it wrongly. Do you have any questions? Is it Zimkita? Zimkita, do you have a question? Okay, it seems that she might be listening to the minister at the moment. Okay, I'm just going to move up the list to make sure I didn't miss anyone. Isabella Governor.
Good morning, ma'am. How are you?
Good, and you?
I'm very well, thank you. I wanted to know, how does the equation y equals mx plus c, how does that apply to a straight line graph?
Okay, so the m over there that you get in your graph is your gradient. And as I said, later on, we will look at all of those things. So the gradient is how steep this straight line is on the axis, and your c is actually your y-intercept. So if they give you your y-intercept and they give you your gradient, you will be able to draw that graph without making use of a table.
Okay, thank you very much, ma'am. Enjoy your day.
Thank you. You too. Bye. Right, I am just moving down to make sure I've answered everyone's questions. But I'm just going to have a look at the questions in the question box. Right, so Isabella is also asking what is the difference between a parabola and a hyperbola. So I want you to go and just Google and look at different images. So it does have a different shape. It does have a very specific different equation. So you won't have your x squared in there. It will be over x. So there's definitely restrictions that applies over there because we can't divide with a 0 and therefore there will be asymptotes. So just go and Google a bit the difference between a parabola and a hyperbola and just see how it looks at this stage. How come trigonometry is in term 4, but we are learning it in term 2? Simkita, this is definitely term 2 work. It's not only term 4 work. Please go and have a look at your work schedule, your year plan, which is in your facilitator's guide, as well as in the portfolio study note that you can download from My Impact. So Jeanette is actually asking to explain the Cartesian slide again. So Jeanette, maybe you should just ask me more specifically about what do you want me there to explain, then I'll do that. And then Simkita also asked if this will be in the June examination. Should a June examination be written, it will be part of June exams, yes. Isabella asked, is an intercept the point on the graph where x and y intercept at the same point? No. So intercepts are where my graph cuts my axis. So if the graph cuts my y-axis, that is my y-intercept. It does not have to be the point where x and y cuts, the one that we've done with the parabola. So if there's a straight line and it cuts my x-axis, that is my x-intercept. And where it cuts my y-axis, that is where my y-intercept will be. So Adrian is actually asking, why does a parabola not have an asymptote? So for us to see if a graph has an asymptote, I need to look at the equation, and if the equation lends himself to restrictions. So like I said, with a hyperbola, there is some restrictions in the equation itself. Stuff that you have learned of that can cause restrictions are that I cannot have a negative value under a square root. So all of the values that will give me a negative value under a square root will be restricted, meaning it can't be that value. That's one example. The other example is that we cannot divide with a 0 as it is undefined. So if you have something over x, it means that my x cannot be 0, and that causes an asymptote. But if you look at the equation of a parabola, x to the power 2, there is no restriction. X can be anything, and because x can be anything, it will not have any asymptotes. Right, Jeanette is asking if I can go through the plotting. Oh, that's on the Cartesian plane slide. I will go there now. And the last one, when will we do a webinar on Euclidean geometry? When we get to that, I first want to finish off on functions, make sure that all of us know what to do there, and then I will move on to the next topic. You will be informed on our Facebook page on that emails that you need to register for. Just keep an eye out for that as well. Parabo asks, is it possible to get a question in the exams without y? No, then it's not a function. You might get something that says fx in brackets. That represents a y. Okay, I'm quickly going back for Jeanette to the plotting of points. Just want to go. So Jeanette, I'm going to do it on this slide as it is the same as the straight line. Okay, so when you have calculated your x and your y points, so this is friends, these are friends, these are friends, these are friends, these are friends, and you're going to use friends to actually determine where you need to put your dot. So 2 friends makes 1 dot, 1 friendship. So you will say that y is equal to 9. So on your y-axis, you will go up to 9 and you will draw a line, a light line for yourself with a pencil. Okay. Then you will take its friend, which is -3 on my x-axis because it's an x value, and then draw a slight line over there. So where these 2 friends meet each other, that is where I will plot my point. That is where I will draw my point. Okay. Then at -1, where x is -1, I'll draw a line. And then again at y is equal to 1, where my two lines meet, as I've indicated here, that is where I will plot my point. Then you take your next set of frames at 0 and 0, and we call this point where both is 0 the origin. Then you will take where x is 1 and y is 1, where they intersect. You will plot your point, and you will go to where x is 2 and y is 4, and you'll plot your point. Now you have your points, and then you will connect all of these points to give you one graph. I hope that it is more clear to you. If you still struggle, please go and have a look at the videos as well, and make sure you understand that as well. Just want to see, why do we only have one webinar a day? So the problem that we currently have is that we can only represent one webinar at a time. So, I am the one person that presents mathematics, but I need to present it for 10, 11, and 12. So it's just a schedule that works out to that you can only present one per day. There's actually 2 sessions, a morning and an afternoon session. It might be that you just don't have those subjects that is presented in the afternoon. So sometimes you will have 2 webinars a day. Karabo, I will put up the YouTube links for you again. All right, thanks, Jeanette. I hope that it's better now. Okay, I'm quickly going to put up the links for you again, just to have a look at. I will allow some time that you can also download this handout, then you have the links as well. So in the handout box, just go there, click on it and download the PDF version of these, and then you have all the links as well. So if you don't want to download that notes, quickly take a screenshot of this, then you have all of these links. Right. So I assume that we are fine with questions and you don't have any more. I hope that I could help you this morning and that you understand what functions are all about. Like I said, this is an introduction to that, and we will carry on with functions in our next webinar. If you are not interested with Impact and you want some more information, please contact us at info. Thank you so much for each and every one of you that joined in this morning and that interacted nicely in this session. I appreciate it. Please be safe, take care of yourself, and stay healthy. Bye-bye.